or what you can do. Well, all of this stuff we're going to be learning this semester. Okay, so the next part we're going to talk about is, again, going back to solving equations and a little bit of applications. But don't worry, not too much, right? So it's more a little bit more solving for stuff. Okay. So in this section is going to be a variety of stuff. So we're going to be solving for rationals, or just a fancy word for saying fractions, and radicals, which is just square roots, which we talked about a little bit, but now we're going to be far more specific when it comes to those square root stuff. Okay. And the last section, we'll just do a simple example of something called similar quadratic forms. Okay. So what we're going to do with the first one is the radical equations. Again, radicals means we're going to have fractions, everybody's favorite, right, when it comes to it. So a rational equation kind of looks like this here, where you actually, again, just have fractions, right? It's like 4 over x minus 9 over 5 equals 4, right, when it comes to it. Now, in order to solve for these type of equations, we're going to do a couple of steps involved. However, before we actually do that, I want to give you guys a quick little rundown, right? So, for example, back in the day, let's suppose we wanted to add these two fractions together. So if we wanted to add these two fractions together, what was the first step we had to do? Everybody remember? Or like you guys like screw fractions, I hate fractions. Just omitted it from your head. Anybody remember? Yeah, good. Gustavo. Common denominator. In other words, we had to have these two numbers being the same, right, at the very bottom. And how we would do that is we figure out, most of the time, again, I'm not saying all the time, but most of the time, to get the common denominator, you just multiply these two out, right? So 3 times 4 gives you 12. So LCD will be, the least common denominator would be 12 in this case, right? And we would multiply what we're missing, right, corresponding to it. And that's kind of what we're going to be doing here. We're always going to be finding the LCD of the bottom of the fractions, and then just multiplying literally the entire equation by the LCD. That's the only little difference between this stuff and what we're about to do. But the same concept comes into play, is figuring out what we're looking for to find those two numbers being exactly the same. Okay. Again, we're going to be dealing with numbers, but it's the same thing applies with variables, x's and 5's and all that fun stuff. Okay, so don't stress. The exact same process you would do if you do, again, you just add rationals together or just fractions. Okay, and that is actually the first step. Again, instead of LCD, it's called the least common multiple when it comes to the denominator. But same process when it comes to it, just different letters. The exact same thing, right? Again, we're going to do for the entire denominators of the equations. So once we find that, we're going to multiply the entire equation by the I think that's misspelled, LCD. Yeah, LCD. Oh, I misspelled that. Sorry, LCD. A quick fix there. I don't know why I put M instead of C. That's weird. Multiply the entire equation by our LCD. And the reason why we do that is because all of the fractions will go away, which is everybody's favorite, right? All the fractions go away, and now becomes a nice equation to solve when it comes to it. Okay, so let's do an example, right? Let's do the first example we did on the last page here. I just go back and do that one. So here, and let's do our first steps. So the LCD is just going to be the multiplication of 5 and x, because that's all the denominators we have. Now, what a lot of people do, and I also like to show you guys, is whenever you have a whole number, just put it over 1. That way you see you want to find the LCD of all the numbers in the bottom. So 1, 5, and x. So if you were to just multiply them, you just get 5x. Right? There is your LCD. And again, in most cases, it's going to be exactly that when it comes to it. Okay. All right, that's step 1. That's all you have to do for step 1. Now for step 2, we're going to multiply 5x times everything on the top. So literally everything. So that's what we mean right here. So it'd be 2 times the 5x, the 6 times the 5x, and the 2 again times the 5x. Now notice a lot of stuff actually cancels. So right over here we get 10x, and over here we get 30x, and here we just get 10x. But notice the x's cancel, and we just get a simple 10, no more fraction there. And notice 30 divided by 5 is just 6x. So again, it goes away. And here we just never had a fraction. And that's the main focus of what we want to do, is we're not technically solving as it's just this process makes it a way to make it look a much solvable process to do with. And then from here, we just solve for x just like we've done normally when it comes to it. But the whole goal when it comes to these type of equations is first manipulated it to make it look nicely when it comes to it. And that's the whole process, just making it get rid of the fractions to make it nice and easy. And then from there, we just solve for x accordingly, right? So for this case here, we would add 6 to both sides. So we just add 6 to x both sides. That's how we get this, and then just divide by the 10, right? So we would have 10 equals 16x, and that's how I got those there, right? Divide both sides by 16, and just simplify. Okay. So let's try an examples out so what you could see, you're going to see on the homework and also on the exam, so you guys can a little bit more up a completion when it comes to it. Okay. So let's just first start with a simple example, and then from there we'll go a little bit more complicated when it comes to it. Okay. So all these are going to be solving. Okay. So let's suppose we have, what do I want to start with? Well, let's just do some homework questions. How about that? You have less homework to do actually too. Yeah. Let's try this one. Very similar to the one we just did above. Okay. So say this is A. I'm recording, right? Yeah, recording. So step one, we want to find an LCD, which again is most cases just multiplying those out. So if we multiply 2x times 3, that gives us 6x, right? So we found our LCD. Step one, check. So now step two, we're going to multiply all of the tops, right, by our LCD, by 6x. So it's going to be 5 times 6x over 2x plus 2 times 6x over 3, and then 6 times 6x. And then we just multiply and then simplify, right? That was pretty much step 3 there. So that gives us 30x over 2x, 12x over 3, and then 36x. So simplifying here, 30 divided by 2 is 15. And the x's cancel because x divided by x is just 1, so that just goes there. Plus 12 divided by 3 is 4. And again, this is just 36x, right? And now notice it's exactly the same template we had above, right? So now we just solve for x like we did before. So subtract 4x to both sides. And just divide by 32. So x is going to be 15 over 32. And there's your answer. Okay. Questions there at all? Everybody comfortable? Okay. So if there's no questions there, let's try a little bit more advanced one, like a medium-sized one. Okay. So this one, let's say we have this. All right, so we have a lot of stuff on the bottom, right? But the kind of same template comes into play, right? This is a 0, which is even better, so no number over here. So first thing we want to find is the LCD. So again, in most cases, it's just going to be the multiplication of this, but I'm not really going to multiply. I'm just going to say I'm multiplying like this. So I know it's the multiplication, but I'm not going to FOIL it out just yet. I'm just going to write it just like that, make it easier. Okay. So now when we go to step 2, we're going to multiply all the tops by this. So 2 times that and 3 times that. But again, I'm not really going to multiply just yet. I'm just going to write it as if I'm multiplying. So in other words, like this step here. So it'd be 2 times x plus 1 times 5x minus 2 all over x plus 1. And same thing on this side here. Okay. Now, the reason why I'm not technically going to FOIL this out is because, remember, the whole point is to get rid of the fraction, right? They simplify to get rid of some stuff. Now, notice, things actually do cancel out here. I have an x plus 1 at the bottom, and I have an x plus 1 on the top. So therefore, they actually just cancel away. Same thing over here. I have a 5x minus 2 on the bottom and a 5x minus 2 on the top. So they also just cancel away. So really, step 3 now becomes very nicely, it's just 2 times the 5x minus 2. That's what's the only thing that's left over. Plus, and on this side, it's going to be 3 times the x plus 1. Again, that's the only thing that's left over, equals 0. So now look how nicely that ends up being. Okay. So that's why I'm saying you don't actually want to FOIL this out, because the whole point is to cancel stuff out at the very end once you multiply the tops. So a lot of this times it's going to be not really multiplying. That's the key thing. It's just, factoring at the very end and just canceling everything out as much as you possibly can. Okay? And then at this point, we just, distribute in both cases and then solve for x. Okay. Add like terms, so 10x plus 3 is 13. Negative 4 plus 3 is negative 1. Bring it over. So x equals 1 over 13. There you go. Any questions there? So far, so good? So, all good? Okay. Assuming all good? Okay. All right, so that's what I consider a immediate problem. So I'd say this is an easy problem, a medium problem, and so let's do a little bit more difficult one so you guys can see the difference of this. So what do you mean by more difficult? It just means more work. That's pretty much what it means by difficulty, right? It's probably what you guys think of, like, oh, it's difficult because you have to do more work for it, right? But it's not like it's really, really hard when it comes into play. So let's try this one out. Now, the reason why this is a little bit more difficult is because it's actually a trick question. Okay, so before we do this one, let's suppose if we go back to our fraction portion, we had this. Okay, very little simpler, right? And let's suppose we want to find the LCD of all of the denominators of those. Now, like I said, right, I told you guys, in most cases, all you have to do is multiply the bottoms and, you get your LCD. However, again, this is why it's a little bit more difficult. This one, you don't actually have to do that, because if I just go here, what's the LCD of just 3 and 2? What's that going to be? Yeah, 6. And notice I already have a 6 there, right? So just if it's the exact same as your LCD, well, that's it. You actually don't have to multiply all 3 of them together. It's already there, so we're actually done. So that's the same thing process we're going to do here, is if we have all the combinations in one of them, we don't have to actually multiply again when it comes to it. So what I mean by that is, well, this one's a little bit more work, because let's actually factor this out. Okay, and don't worry, we don't have to do a quadratic. This one actually factors nicely, which is the best part. All right, so let's see what we get when we factor the bottom of this this rational. So it's going to be this method, and then 1 times -3 is just -3, and that's a 2 down there. So even better, because they're low numbers, so not too crazy. We have to multiply, right? So 2 numbers, when you multiply, give you -3. Well, there's not a lot, right? So there's -1 times 3, and there's also 3 times -1, right? There's no other choice from those. So the only one, when you add them, give you 2, is going to be, well, these are the same thing, right? Sorry, -3 plus 1. So the only ones that make it work is that pair, right? So -1, 3, that's our pair. So therefore, those are our factors. So it's going to be x minus 1 and x plus 3. And again, notice that's actually what we have there, right? Put them together, there we go. And that's the process when it comes to this LCD. If you have it already, right, both combinations put together, that's exactly going to be your LCD. So in this case, step 1, our LCD is exactly x minus 1 and x plus 3. Okay, so again, before we go any further, any questions on that at all? No questions? Okay. So now go on to step 2. We multiply all the tops by our LCD. So it'd be 2 times all of this. Again, we're really going to multiply, because just like the last question, it's going to cancel stuff out. And then just like the last part B, I see what cancels. So if notice over here, those cancel. Over here, these cancel. And even better, everything cancels over here, right? Except for that -5. So for step 3, this now becomes 2 times x minus 1. What's left over here? Over here, we get the 5 times x plus 3, because that's the only thing that's left over there. And this whole thing equals, this focuses on nice. Maybe it's can't focus nicely. So it should be -5. So focus. There we go. Okay. And again, now we just multiply and distribute and just solve for x accordingly. So distributing here, distributing here. And again, just collecting like terms. So that and that gives you negative 3x. This and this gives you negative 17. Add 17 over. That is 12. And then finally dividing by negative 3 gives you negative 4. That's your answer. And there you go. So any questions on this one at all? A little more difficult one. No questions? Okay. So in that case, let's do another one for a little extra credit one. So let's suppose we have this scenario. So first off, what do you guys think our LCD would be? Because remember, this one already has an X. What do you guys think? What is the LCD? I'll give you a hint. It's a trick one, just like it was last time. Looks like Jonathan got it. Yep, it is just 4x because they already have an x in common, right? Just like this one, they already had everything in common. So it's just a combination of them. So be careful about that. So it's just 4x. All right, so now that you have 4x, go ahead and finish it up. And the first 4 people in the chat that get it will get the extra credit. So what is x equal to if you finish the problem up? Not quite, Jonathan. Try it again. Almost there, though. Be careful when you multiply. Keep going, guys. What do you guys get? Mhm. Be careful, Heidi. A little off there. Give everybody another 30 seconds to finish up. Okay. All right, good. Looks like a lot of you guys got it. So let me just go through this real quick. So now we will multiply everything by our LCD. And notice that's nice. All of that cancels. So you just get 1 here. Over here we get 8x over x. And here we get 12x. And again, that's nice because also those x's cancel. And we're left with 1 minus 8 equals 12x. Subtracting those gives us -7. And then divided by 12, we get the -7 over 12. There you go. Good job.